Hey guys, it's Mr. Marabella here. I just wanted to do an example problem for you for free fall motion, which is just a specific type of accelerated motion that we've been dealing with. So all the Vivovidat charts that we've been working with up until this point are going to follow suit with this type of example problem. So the sample problem reads: a student drops a penny from the top of the Empire State Building, which has a height of 443 meters, in an attempt to strike an unaware pedestrian, Mr. Marabella. Two questions we're going to find out. How long will it take the penny to reach the ground, and what is its final velocity before it hits the ground? Okay, so I'm going to go ahead and set up my chart. Now in this case, we're going to actually change it to delta y, and that's because the position changes in the y direction. Okay, looking through the problem, key piece of information, 443 meters, drops. We want to know how long it'll take the penny to reach the ground, and we want to know the final velocity. Now what's a little bit different about these word problems compared to the ones we had before is by knowing it's a free fall motion problem, we know that the acceleration is going to be negative 9.8 meters per second squared. Okay, that's our field acceleration on Earth's surface, and it's going to be a fixed value that we use throughout the course. Other key things. All right, if someone's dropping something, all right, we're not throwing it down. That means the initial velocity is going to be 0. Okay, and then the height of the building, 443 meters. Since the object is moving downward, and we say in physics here for us, downward is a negative direction, right? The object's going to fall negative 443 meters. All right, so we're in business with our Vivovidat chart. We have our three known values. That means I can pick an equation to solve for the other unknown. So the first one in question is how long? How many seconds does it take for the object to fall the 443 meters? So when we're picking an equation, all right, we can't have two unknowns in it, so I'm going to pick an equation that doesn't have VF in it. And it's going to be this one. All right, displacement in the y equals initial velocity times time plus 1/2 times acceleration times time squared. Now notice here with this problem, since there's no parentheses, right, only time is being squared. Right, subbing our values. Okay, since our initial velocity is 0, 0 times t is 0, right, this whole thing's going to cancel out. So we really just have 1/2 times negative 9.8 times t squared. Okay, the rest of this point is really just the algebra. So I'm going to go ahead and jump to the final answer. Actually, we'll show out the math. So negative 443 equals negative 4.9 times t squared. All right, divide by negative 4.9. And we end up having space. All right, we end up having all right, negative 443 divided by negative 4.9 is 90.4 equals t squared. And to finish off, we're going to take the square root of both sides. So time that it takes for the object to fall is 9.51 seconds. For the second part of this example problem, we're trying to find the final velocity just before the object hits the ground, right? In this first part, we figured out how much time it's going to take to get here. Now, usually what I say when we're doing problems like this, if at all possible, try and avoid things using things that we solve for to solve for other things, right? Because if we made a mistake here, we're now going to make a mistake finding the final velocity. So our original two unknowns were time and final velocity. I'm going to stick with the methodology we've been working with. All right. Pick an equation that does not have time in it. Okay. That one is going to look like this. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement in y. Alright, this one works out nice. Vf squared is already by itself, so I'm just going to evaluate the right-hand side and then take the square root. So we have 0 squared plus 2 times negative 9.8 times negative 443. Okay, so if we evaluate this whole side, we get Vf squared equals 8,682.8. Okay, and finally we're going to take the square root. Now we got to remember, when we're taking the square root in mathematics, we end up with a positive and negative value. Okay, this leads to a little decision making on our part. Right? Should the final velocity be positive or negative? Well, if we've established that the object's falling downward down the negative direction, right? It's being accelerated in the negative direction. Right? I'm actually going to use the negative here when I take the square root because, right, my object is traveling downward. So our final velocity will be negative 93.2 meters per second.